So we'll start this session. Uh, this session is Introduction to Pandas, which is a continuation for the previous session, Introduction to Machine Learning, in which we have discussed about supervised, unsupervised, and reinforcement learning. And we have also discussed about some of the models like regression models and decision trees and random forests. So, Introduction to Pandas. So, first things first, what is Pandas? Can anybody just tell me in one sentence what Pandas is or what Pandas does? Okay, I'm not, okay, this is not any sort of a lecture or something. Let's make the session interactive and please, you're free to speak. Nobody's going to judge you, so you can speak up. Okay, yeah. Mm-hmm. Yes, yes. Okay, so what Suraj said is right. So Pandas it is an open source data manipulation and analysis library for Python. So like I said in the previous session, when we are dealing with building models with machine learning, we need data, and data is not always complete. We always have empty rows or empty columns or empty cells sometimes, and we need to manipulate the data, we need to clean the data, we need to transform the data into the way we require so that we can feed it to the machine learning model to get the best output. So Pandas is one of the most famous and most blooming library to work with data, and it is very easy to use. So why Pandas? Like I said before, we need to clean and then transform the data and analyze the data. So Pandas will help us with different types of the classes and the methods and different types of functions, which makes the complex tasks easier for us to change the data. So diving into the some of important in this session, we're gonna look at some of the important functions and methods we use in our daily life while dealing with machine learning, and those functions will be explained in this session. So, can I is my screen visible? I shared my screen, the collaboratory file. Yeah, yeah. Thank you. So, beginning with pandas. Uh, there is a main a data type in pandas, which is data frame. A data frame is simply a tabular arrangement of data, and series is simply array kind of data. So these two are the important data types in pandas. One is data frame and another is series. Data frame is a tabular kind of arrangement, and series is a linear arrangement. So we'll be beginning with importing pandas, and we'll be giving it an alias as PD. So we import pandas as PD so that while writing our code, we don't need to always mention pandas. We can simply write PD dot data frame, PD dot and you can PD dot series and all these methods. So once we have imported pandas, we'll be creating a simple data frame like you'll be passing a map like this, in which the keys are the titles of the columns and the values of that respective key will be the rows. So in this data frame, the first item is yes, and it has a value of an array of 50 and 21. So the first column will be yes, and the elements of it are 50. The first element is 50, and the second element is 21. And the second item of this data frame is no, where the first element is 131 and second element is 2. So the heading for this column will be no, and the first element is 131 and the second element is 2. This is a very simple data frame which we are doing it manually. But while you are dealing with data sets, you'll be reading the CSV file and then putting it into a data set in which it has thousands and lakhs of rows, and it will be handled very easily by pandas. So this is a simple data frame and this is how it looks. Okay, so and we'll be looking at another data frame. We always don't need to only take only numbers. We can also take strings and many other data types. It is the only flexibility we have with Python. So pandas.data frame in which the keys are Bob and Sue, then it is their names, and the Bob has two dialogues, one which is I liked it and it was awful. And Sue has two dialogues, pretty good and bland. So it is formatted into a data frame, like we said before. The Bob is the heading, and these are the dialogues, the first dialogue, the second dialogue. And Sue is the heading, and this is the first dialogue and the second dialogue. So this is a simple data frames. And we have only provided Bob and its dialogues and Sue and their dialogues. But we are also getting this 0 and 1, which we call it as index. We usually do not provide index to data frames. It will by default take indexes starting with 0 and it will assign them automatically. But if you want to change the indexes, there is another parameter for the data frame, which is index parameter. You can pass that argument and provide it a list like product A and product B or whatever you need, like index A and index B, and it will be executed. And one more thing you have to note here is the length of the index must be same as the length of this map. In this map, we are having two elements, which is Bob and one is Sue. And the index also must have two elements, index A and index B. If you are only to provide one element here, you will be receiving an error. Yes, the length of the values does not match the length of the index. So the length of the index must be as same as the length of the data frame. That's how it happens. So data frame is like a tabular arrangement, whereas series is an array-like arrangement. So if you have to create a series in Pandas, you can, like I said, it is an array-like arrangement. So you directly create the series with an array. Like you'll be passing the array 1, 2, 3, 4, 5, 6, 7, whatever you need, or you can even pass text like hello and world, and you'll be getting that. Yes. And even for series, the indexes are assigned manually. The indexes are assigned automatically. So in this series method, you can also pass index like you do for data frames. And like the same rules for data frame, the length of the index must be as same as the length of the series. And you can also give your data frame or give your series a name like product A or my product so that you can easily identify the series or data frame. So yeah, these are the two important data types in pandas, of which one is data frame and another is series. And in most of the time, when you're dealing with machine learning, you often use this data frames and series for manipulating and formatting and transforming the data. Coming to dealing with CSV files, Pandas is very helpful in reading and manipulating data, like I said before. And you read CSV files by passing the method read underscore CSV, and you store it in a variable called data. So data is equals to pandas dot read underscore CSV, and I have a CSV file here, which is housing prices dataset. And I've also explained the contents of housing prices dataset in my previous session. And so you read the CSV file and it will be automatically converted into this data. You can print the data like such. So pandas is most commonly used for dealing with CSV files. And for printing the shape of the data frame is the number of rows and number of columns. So you can come to know about the shape of the data frame using the data dot shape method, so that it will be giving an output of number of rows and number of columns. This CSV file has 544 rows, 545 rows starting from zero. The machines count from zero, and 13 columns. So the shape is 545 and 13. And when you're dealing with data, you need to know what kind of data, what are the names of the columns and how is the data arranged and how does it look. And you need at least a little bit of sample from that millions of rows so that you can further calculate on how to manipulate the data. So to have a look at some of the rows, you'll be using the head method, which is another important method in Pandas. So that when you use the head method, you'll be getting the first 5 rows of your data set and all its data organized. So the head method will be giving you is giving me all the first five rows and all the columns from that data set like price, area, bedrooms, bathrooms, stories, etc., etc. So you can also, okay, like I said before, the indexes of this data set, indexes of this data frame will be assigned automatically, starting from 0, 1, 2, 3, 4, and so on until 544. But if you want your index of your data frame to be different, you can also do that by passing the index underscore call is equals to 0. There are different kinds of data sets. Like I said before, all the data sets doesn't look same. They are not arranged in specific order. They are all clumsy and they are all different. Some data sets might have some datasets will get index pre-assigned, and some dataset don't have index. They are directly start with the data. So if the dataset has pre-assigned indexes, if that CSV file contains indexes before on hand, so that you can pass the indexes to your data frame without the pandas considering that index column to be some sort of data and reassigning the indexes automatically. You can pass any of the column of your CSV file as an index, and that can be done through this index underscore call argument. And you have to specify the index of the column so that you'll that so that the pandas will consider that column to be the index. So while I'm reading the data set, I'll be passing the index underscore call is equals to 0 so that the zeroth column, which is price, will be considered as my index. If I pass it some other column, I'll be getting bedrooms as my index. So that is how you can manually change your indices. I'll be leaving it to 0 for now. So yeah, and if you have to select a specific column from your dataset, you will be using the there are two ways to do this. The first thing is you can pass the column name as a method from that data frame, which is if I had to select the column area, I can directly call the data variable and then directly pass this dot area as my method, so that it gets me the all the value from the price column. So if I pass some other argument like some other method like bedrooms. Okay, so it will be so yeah. So initially I've given the index as price so that I'm getting the index as price and I'm getting the data of bedrooms over here. So if I pass area, I'll be getting the index as price and I'll be getting the area. If I pass it some stories, I'll be getting the index as price and I'll be getting the stories. If you had to remove this, if you remove the index underscore call parameter and execute it, and when I hit dot stories, I'll be getting the index as the pre-assigned index, and I'll be getting the data of the stories. So that is how you can call a specific column from your data set. And the other way of calling your columns is by passing the by like you do for maths, you can pass the square bracket and pass in the name of the column as string so that it will bring you the data from that column. I'll be getting the indices and I'll be getting the area. You can also pass other columns also, and you'll be getting that data as columns. So these are the two main methods you use for printing the columns out of a data set. But the first method is to directly pass it like a method for that data frame, and the second one is to give it a square bracket and pull it out of it like a key value pair. So if I had to get a single value from that specific column you choose, like if I choose the column area from my data set, and if you have to print uh, a specific row from it or a specific value from it, I have to pass its index. In the same way you pass the area, you pass the index also. So initially, I have my index as 0, 1, 2, and etc. So that I'll be passing the index as 0, so that I'll get 7420 as my first area. If I pass some 100 index, I'll be getting my 100th area. So that's one of the method you can pull. row out of you can pull a row out of your column. And ilog and log are another two important methods of pure data frame, where if you use ilog, which is index location, you can it doesn't deal with any of your indices. Like let us say if I read this data set and I give the index column as 0, which is I'll be assigning the indices as my price. And when I execute it, all my price column will be attached as indices. And if I had to print the first or the 100 row from my column, I'll have to pass this parameter as 100, or if I pass this parameter as 0, it will not be accepting it because the indices are actually the prices. I have to pass any one of the price so to get my first row or your desired row. So at the 2 minutes back when we are doing this, I can directly pass indices as 0, 1, 2, 3, so on, so that I'll get my area. But now I have to pass this price, which is 13 million or something, so to get my area. So this directly depends on the index, which is in some cases where you have multiple rows of data, you don't know the price, or if you assign this kind of price or area to as your index, you don't always know what the values are, or you don't always, it is hard for you to pull the data out of it. So, uh, so the best method of doing it is ilog and log. So the two main differences are if you use ilog, it doesn't care about the index and it will directly accept arguments as 0, 1, 2, so on as your index, and it will print the 0th row or first row or second row or so on. And whereas coming to log, it will care about the indices. If you are caring about the indices, you can use the LOC method. And if you are not caring about indices, and if you want to easily pull your desired row from your dataset or data frame, you can use the ilog and you can pass your desired number so that you will be getting the data out of your data frame. So this is the 100, this is the 200 data, and it is easy. And if I pass the same 200 to this LOC method, I will not be getting the data because my indices are prices and I have to only pass this price to my LOC method. Yeah. So that's everything about ILOC and LOC. And we can also filter your data based upon your conditions, which is if you use the LOC method, and you can, if I want to get all my houses from my data set uh, where the house is situated on the main road is true, which is if you carefully look at the data set, the main road parameter can only take two values, which is either yes or no. So if I had to filter all my houses which are lying near the main road, which is I have to take data dot main road is equals to s. So I'll be taking the LOC method and I'll be filtering it with data dot main road is equals to yes. And when I do that, all my data will be filtered in such a way that I only get the houses where the main road value is 2. If you look carefully, you'll be observing that all the values in the main road column is yes, and and the size of the data frame is also differed by it is having 468 rows, whereas our original data frame size is 545 rows. So the other rows are with main road is equals to no. And if I had to filter with main road equals to no, and I'll be getting the data where main road equals to no. So these are 77 rows and 12 columns. And you can also, and the other important method in this filtering techniques are the ease in method, where you can, if they, so when I was talking about main road is true or false, which is yes or no, I only have one condition. But what if you have multiple parameters in a column, such as if it's furnished or semi-furnished or unfurnished, which is if you want to look at the house, if you get satisfied with the houses with the furnishing status as either furnished or semi-furnished, but you don't want any kind of unfurnished houses, and how would you do that? You can't filter the same data two times, right? So you can use the easing method where you will choose the okay. In the first place, you'll consider the data frame and you'll use the LOC method. And in that, you are selecting data's furnishing status column, where the column has values of furnished and semi-furnished. I'll be changing the status to semi-furnished and execute it so that I'll be getting the data where the furnishing status of the house is either furnished or semi-furnished. So I don't need any houses with unfurnished status, so that I'll be applying multiple filters on a single data frame at the same time. If I had to do this via this kind of double equals to operator, I have to apply the same method two times. But this isn't method will simplify my process of applying multiple conditions. So, like I said before, a data frame might contain empty blocks or empty cells, or there are incomplete data, and in some cases, the data doesn't exist. It will be either not available or NA, or it will be just empty, which is null. So, when you are feeding a data frame to a machine learning model, you must have a complete data. If there are incomplete data, even your model has to perform perfectly. It will not perform perfectly because it has null data. So it cannot train properly because of the null data, which will affect your performance of your model. So in some cases, we'll directly remove all the nullable rows or nullable columns from that data. Or in some cases, we take average of the upper and lower rows or columns. Or in some cases, we fill the null columns with by calculating some mathematical equations, which we'll be looking in the further sessions. And if you have to filter where in your data frame you need all the data in which is not null, you can directly use the not null method or is null method to get all the nullable data. So when I execute this data.clock where data.area is null, I have yeah, I have no rows over here, which is I don't have at least one row. I have zero rows in which the data is null. So if I get not null, if I type not null and execute it, I'll be getting the all the rows because I get all the 545 rows because there are no null columns in terms of area. Okay, so what if you had to rename some parts or some columns of your data frame uh, so that it makes it easier for you to work with, or it makes easier for your model to work with. You can use the rename method directly on the data frame to rename whatever columns or rows you want to rename. So you can use data.rename and you can pass, there are different kinds of parameters for this like mapper and index, or you can rename columns, you can rename axes, and there are, the level, in place is a parameter where you are directly modifying the data frame or you are making a copy of it. I'll be explaining it in a few minutes. So we'll be renaming the columns to story. Okay, let us rename the column stories to floors. So if I had to do that, I'll be passing the columns argument and I'll be giving a map of rename the column stories to flows. So, and when I execute that, I'll be getting the data frame I'll be getting the data frame in which the stories column is renamed to flows. But what if I re-execute the previous, the data frame? Let us do that once again. So if I execute this data.head, but here I still see the name stories. But here, when I rename here, but it is showing me flows, which is the in-place argument will take care of this. The in-place argument deals with manipulating the original dataset or creating a copy of the dataset. By default, the in-place is false, which is when you execute the rename method, it will create a copy of the dataset and it will rename or your desired changes for you. If you keep in place to true, it will directly manipulate the original dataset, but it will not make any copy of it. So that is how you can rename columns or items in your data frame. Okay, and you can also set index to your custom indices like I did here. Like you can directly use the method set underscore index on your data frame and you can set index to your data frame, and this method will be replacing the current index, which is here you can observe that I have index as price. These are all the pricings of my houses, and I set it to be the index for the data frame. But when I use the set underscore index method, it will directly replace the indices and it will totally remove the price column from the data set. You cannot observe the prices here because the prices is being as the index, and when I apply the set underscore index, it is replacing my array of indexes with the price. So I have generated 544 numbers random in a sequence. I use the range method from Python, and I've set the index so that it is replacing my prices which are lying as index with these numbers. If I use some I plus 5, you'll be getting 5, 6, 7, 8, 9, and so on. So that's how set and score index method works for renaming or changing the index in your dataset. So describe. Describe is another important method used while dealing with datasets. A describe method will provide you some of the famous or some of the popular mathematical, what do you say, mathematical functions or mathematical derivations, which is the count, the mean, which is average, the standard deviation, the minimum, 25%, 50%, 75%, and the maximum value from that specific column. So describe will give you an overview of what your dataset looks like, and based upon that, you can choose your model or you can choose your algorithms for building your machine learning model. And describe function only works with numbers because you cannot get averages and standard deviations on text like yes or no. So it will only consider all the columns with numbers and it will give you the data for that. And you can also calculate mean, standard deviation, etc., and other mathematical functions on specific columns applying that by applying that operation on the column you choose, which is data dot. I've chosen the column area and I'm applying mean on it so that I'm getting the average as 5150. So 5150 is the total average is the average area of houses in my data set. So if you are to create, if you are to get unique data from your columns, you can also do that by calling the unique method, which will give you only the, it will give you the unique data from your column. So I've applied it on area. What if I apply it on guest room or basement? I'll do it on main road. So if I apply it on main road, I'll be getting only two, which is yes or no, because the main road is taking only two values, yes or no. And if I apply it on furnishing status, it is either furnished or semi-furnished or unfurnished. I have three unique values from the column furnishing status, and unique is also one of the important methods in Pandas. So you can unique what does unique method do? Unique method it will display you the overall what are the values it can take, which is furnished, semi-furnished or unfurnished in the case of furnishing status. And what if you want to know how many furnished are there, how many semi-furnished are there, or how many unfurnished are there? Like if you want to know how many times the each of the value is repeated, you can use the value underscore counts. If I consider furnishing status column and if I apply the value underscore counts method on it, I'll be getting the semi-furnished value is repeated for 227 times, unfurnished for 178, and furnished for 140 times. So that's how value underscore counts work. And you can also group the data by specific columns or specific, specific. You can also group your data frame by specific columns. And I am grouping it by stories and I'm taking the count for it. So I get the count. The number of stories is, so I am grouping, okay. If I group the data frame by stories, uh, I'll get, so the one story building are 227, the two story buildings are 238, three-story buildings are 39 and four-story buildings are 41 because I am grouping the data frame by stories and I'm taking the count for it. So this is another important method in Pandas. If you want to reset the index of your data frame, like let us say if you have applied some of the column, or you have generated your own index and pass it to your data frame, but later while you are dealing with data and you have written a lots of code, and it is hard for you to manually go and change the index everywhere, you can simply do it by resetting you can simply reset the index by passing the reset underscore index method to your data frame, and it will reset the index for you. Okay, I'll just print the data dot head so that you'll get a clarity of how it works. Yeah, so my index is reset. And if you, yeah, fill NA is another important method, which is, like I said before, data is always not perfect. It will have some voids in it, like it will have null values. If you have to fill all the not available or null values with some value, you can use the fill NA method. And there is another method called drop NA, uh, which will drop all the incomplete cells or incomplete rows from your dataset. So drop NA and fill NA are very useful while cleaning your dataset, and cleaning your dataset is very important while you're feeding it to a machine learning model. So all the functions I've covered in this session are available on in the Kaggle course, which is Introduction to Pandas. Okay, so I'll be sharing that tab too. Okay. So yeah, this is the Pandas course on Kaggle. You can get your certificate by finishing this course and exercises. And yeah, you can go through I have explained the same methods and concepts in this session, and you can go through that, and you can manually choose your own data set and work on it. You can play with the functions, and further documentation is available on Pandas official documentation website, and you can go through that, play with the data, and meet you in the next session. I'll be sharing all the required links, and I'll be sharing the collaboratory notebook with you in the group. And if you have any questions or doubts, you're free to ask. Okay, so like I said in the last week, the group is open at discussion centered. So if you have any doubts or if you want to discuss something, you can ping in the group, and I'll be sharing all the resources in the group. The session has ended for today, and thank you for joining in. Okay, thank you for joining in. I'll be ending the meeting soon. Thank you, Hania. Glad you're here.